In this video, we're going to see another efficient sorting algorithm. This time, we're going to take a look at mergeSort. So the way mergeSort works is we take our array of elements and we split it in half, and then we split those two halves in half, and we keep doing this until we have a bunch of subarrays of size 1. Now, one thing to keep in mind is the way we're going to implement this, we're not actually creating all these arrays. We're referring to, for example, this would be the array of index 3 to 3. This would be the array of index 0 to 3. This would be the array from index 4 to 5. This would be the array of index 4 to 6. So that's how we're going to refer to these. So we're going to be using the same array throughout our algorithm, but conceptually when we call the mergeSort method, we're going to pass the indices of that subarray. So here's our individual arrays, and now that we've broken them apart, we're going to merge them together, sorting them as we go. So we merge 9 and 2 together, and since 2 is smaller than 9, we put the 9 first. 6 and 7, 1 and 5 are already in order, and then 3, there's nothing to merge with. Then we merge these merged arrays. So here, 2 is smaller than 6, 6 is smaller than 9, 7 is smaller than 9, 9 goes in the last spot. Here, 1 is smaller than 3, 3 is smaller than 5, and 5 is all that remains. And then we merge those subarrays to give us our final sorted subarray. So our implementation of mergeSort, we're going to have a mergeSort method that's going to take an array, and that's going to call a helper method that passes in the indices of the subarray. Initially, the subarray is from 0 to the end of the array, so it's length minus 1. And in that mergeSort array, we're going to calculate the midpoint. We're going to merge sort the two halves, and then we're going to combine those two halves together. And notice this is recursive, and so to merge sort this subarray, we would divide this in half as well. So let's suppose we have some array that we're going to merge sort. So we calculate the midpoint. The min is 0, the max is 6, so the midpoint would be 3, which is this element right here. So we're going to call mergeSort data 0, 3 from index 0 to index 3. Then we're going to merge sort the second half, which would be from index 4 to 6, 4 being mid plus 1. So we sort this piece, and now that's sorted. And so we need to merge those together. Now we'll see a specific implementation first, but for now, let's assume that this doesn't merge. It's going to merge the data where 3 is the midpoint between 0 and 6. So we essentially break that array up. Now again, this is conceptually. In memory, it's still one array, but we're treating it as two separate pieces, and we merge those together into a fully sorted array. This piece was sorted, this piece was sorted, and then when we merge them together, we have all the elements of this array sorted here. In our implementation, we do actually create an array of comparable objects, and that's just to make our merge method easier to understand. If we didn't create this full array, then we would have to do some manipulation to map our temporary array's coordinate index back into the index of the original data array. To avoid that confusion, we're just creating an array of n elements. Now the downside of this is technically an order n operation, and so we're doing that a lot, meaning we're going to blow up which for mergeSort, of course, since it's an efficient sort, is not something you want to do. However, for simplicity's sake, this is how we're going to do it. And again, just keep in the back of your mind that if you really want this to be efficient, you need to create an array that's the size of the subarray you're working with, and then copy those elements back in. So our merge method is going to work on part of the array. So for this call to merge, we're only going to be concerned with the data between 0 and 6. We're going to ignore the rest of the array for now. So we're going to create this temp array, keep that in mind, and then the merge method will sort these elements into our temp array, and then we're going to copy those elements back. So that's sort of at a high level how merge is going to work. So let's see the specifics. So we're going to get the start and end points of the two partial arrays that we want to merge. So here we have our data, and you can see we have some calculations. First one and last one are the start and end points of the first array. First two, last two are the start and end points of the second array. and index is where we are in the combined array. So here we have these calculated. First one is 0, last one is 3, from 0 to 3. First two is 4, last two is 6, giving us this subarray. And now, while both subarrays have at least one element, and when we say have at least one element, keep in mind that we're talking about the subarray having size 0 at that point. We're not actually emptying out the array at any point. We're going to compare the first element of each array, whatever elements first one and first two are pointing to, and then we're going to copy the smaller of those elements into a temporary array. So here we have our loop, while first one is less than 1 and while first two is less than 2. So that's these two indices here and these two indices here. So here we have our values displayed on the array, and you'll notice we don't really care about the end of the array, so we're not worried about showing those here. So while first one is less than last one, first two is less than last two, that means there's some elements in these subarrays to look at. We're going to compare the elements that first one and first two are referring to, and if first one is pointing to an element that's smaller than first two, we're going to do some stuff. However, that's not the case, so we're going to do the else case. And we're going to say that the index of our temp array is going to be set to the value that first two is referring to. Then we need to make sure that we increment the starting point of the array that we copied from. So notice first two is now referring to index 5, and we increment our index. Again, now we're comparing first one, first two, and now the element that first one is pointing to is smaller. So we're going to do this first loop. We're going to copy 2 into our temp array, and then we're going to increment first 1. Then we compare the two first elements again. 3 is smaller, so we copy that. We increment first 2. Then we compare the first elements again. 5 is less than 6, so we copy 5. And you may wonder why the values in the arrays that we're merging remain there. And the reason is that's part of the original array. However, in our merge method, we're really just focused on the values in the original array between first one and last one, between first two and last two. Those are the values that we're merging together into the temp array to be copied back into the original array later on. So notice that first one has gone beyond last two. So that means that now we're going to copy all the remaining elements in the non-empty subarray, because the second one was empty, into our temp array. So that's this piece of the code. And notice this condition is going to pass because first one is less than last one. So we're going to copy each element, incrementing first one in index as we go. And now we've completed this first loop, because notice first one is now greater than last one. And this condition is going to fail. And as a reminder, remember our first loop where we were comparing the first elements of the two subarrays had these same two conditions. So this while loop will continue until one of these conditions fail. Well, here, what that means is that one of these conditions will pass and one of them will fail when we get to this code, because one of them failed here for us to exit out of the loop. So we would never actually execute both of these loops, because this condition we check here, and then we check the second condition of our while loop here. So both of them are checked, but only one of them can possibly be true, because while they're both true, we continue the loop. So now we're going to copy all the elements from the temp array back into the original array in their proper location. So we have our data array, we have our temp array, which remember is bigger than we showed because we allocated the size of that original array. But again, we weren't concerned with that before, but keep in mind there's a lot of wasted space. And that's in addition to the space that mergeSort wastes because of all the recursive calls. We also have a little bit of space waste here each time because of these extra elements we allocate. So what we want to do is we want to take what's in our temp array and copy that into our data. So we don't care about last and first and all of those values anymore. We really only care about our index. And this loop is going to reset index to 0, and then we're going to start copying our data. So when index is 0, we copy the 1, then we copy the 2, then we copy the 3 at index 2. At index 3, we have 5, so we copy the 5 back. Then we copy 6, then we copy the 7, and then finally at the last index, which is 6, we copy the 9. So now data looks like this, and all of these values are sorted. And we're going to trust that there was another recursive call that'll deal with sorting these. So in the end, your full array will be sorted piece by piece with those merges that we've just traced through. Now, so far in this example, we've only seen the first half of the full data array actually be sorted. And we're not always going to start at index 0. So for example, we've got to still sort the second half of data. So to sort that second half, again, remember, we've already sorted this first half, so now we're going to sort from index 7 to index 12, and the midpoint there is index 9. So when we do our merge function, first one will be 7, last one will be 9. First two will be the mid plus 1, which is 10, and last is max, which is 12. Again, we'll start the index at 0. We'll do our merge. We'll sort everything into the temp array. We'll copy the sorted elements of that piece of data we looked at back into the original data array. And so now that second part of the data array has also been sorted. So now we have sorted the second half of the data array. We had sorted the first part earlier. And again, remember, we're doing this recursively. So before we even get to the part where we're trying to combine two pieces of data, we've already recursively sorted each individual piece, starting from subarrays of just one element, which are easy to sort, then two, and so forth until we build up. And now we have each half of the array fully sorted recursively. So now we have this sorted second half of our data array. And now we're going to call merge on the entire array with 6 as the midpoint. So we're going to merge those two halves into one final sorted array that's going to include all the elements of the original data array in sorted order. So the recursive pieces act pretty much the same way. All of that happens before any of what we've seen in this video. But from what you've seen here, you should be able to go back and trace through that execution as well. Okay, so this wraps up our discussion of merge sort.